Okay, welcome all to another Gates Australia Power Transmission webinar. Today's subject, we'll be going through drive alignment. For those who don't know me, my name is Ian Street. I'm the Business Development Manager for Gates Power Transmission in New South Wales here in Australia. Been with Gates for over 3 years and have been in the industry for about 30 plus years. Thanks for registering today and logging in, and I hope you'll take something away from today. Just some housekeeping. We have everyone on mute. If you have any questions, you have the facility to type in on our Q&A section there. You might see that on the right-hand side of your screens. So progressively, if they're relevant questions to the topic, we might take them then, but if not, we might take them at the end and we'll just respond to all those questions that you have. Okay, without any further ado, let's go. Okay, just to do some broader things on the preventative maintenance. Obviously, you know, preventative maintenance is obviously going to give you a bit more longevity in your drive. This is relevant to today's subject because, you know, we cover some of the things that have been proper maintenance, which covers about 45% of failure. Improper installation is 20%, and you've noticed there misalignment, incorrect belt tension fall under that category. Improper storage and handling is about 3%. Environmental factors 15%, and poor drive design is about 20%. So alignment is part of what we're going to cover. Obviously, before we get into the alignment things, there's some things that we want to check prior. Obviously, I think this is one thing that is overlooked is the condition of the actual sprockets or drive pulleys. So if you've got the appropriate equipment there or visuals to have a look at them, I suggest it's a great thing to do. Also, you know, sheet cleaning up the shaft with a bit of emery cloth and a bit of lubrication. So when you're actually aligning or setting up the alignment, you've got the actual pulleys sliding freely on your shafts. Okay. Accurate drive alignment is fundamentally important. Proper drive alignment is often overlooked. Drive misalignment, it reduces your belt life, reliability significantly, loads the belt tensile cords unevenly, accelerates V-belt synchronized drive belt failure, may result in early V-belt turnover, increases synchronized belt tracking forces, and increases synchronized belt noise level significantly. I think most of you guys hopefully have been around and you mostly would recognise all those sorts of issues that you face in drives. So, you know, maximise belt life and performance with a proper belt alignment. Accurate alignments begin with the correct measurements. So we'll just start off with that. Traditional ways of checking the alignment. Okay. I think we're all familiar with the straight edge and a piece of string. Now, one of the golden rules is trying to get the 4-point contact of proper alignment. As you can see there in the straight edge, obviously, you know, it's a bit offset, but you only really got the 2 points of contact there. And obviously with the string, although you've got 3 points of contact, you've still got incorrect alignment. Throughout this, you'll see that although it's a proven method, I suppose, of alignment, if done correctly, it's mostly not the most accurate when we get down to it. Pardon my dog. Proper use of the straight edge and string. You can see there, use the straight edges and strings to project the plane of one pulley to the other. As you can see there on the left-hand side, you've got the straight edge flush on one, so you're bringing the other pulley into parallel from that area. The same with the string, you've got 2 points of contact, so you're actually bringing your other pulley in to get your 4 points of contact. As you can see there, we've got some quarter degree to 1.8 per 300 millimetres and half a degree on a V-belt, 2.54 per 300. Obviously, we've converted from imperial to metric there. Okay, the three basis types of belt drive misalignment. The parallel, which is most probably the most common one. The first plane angular, as you can see there, we've just got one slightly off parallel. Then the second plane where you've got off plane parallel and a few other issues going on, which basically your motor needs shimming to a degree. Now, the gates have the Easy Line tool. It indicates all three types of belt drive misalignment. It's accurate and easy to read. That uses the laser reflections and multiple angle of misalignment error by 2 times. So the standard procedure on that, if you can see there, it's obviously got a mirror that's reflecting back into the other one, the other tool. Okay, just to elaborate a bit more on that, we obviously have the transmitter. Now, that is placed on the stationary drive pulley sprocket, and the reflector is placed on the movable motor sheave sprocket. So we use the 3M principle on that, which is the mirror motor movable. That allows you, obviously on the motor side of things, bear with me. Sorry, I've got the council cutting the grass next door and the dog is reacting. The alignment sheaves basically, if you stand behind the motor, you get a better view of the actual drive itself, where you can actually look at the reflection coming back at you, and that will give you alignment off the other tool on the other pulley. And this also includes the alignment of all sheave sprockets, including idlers, as they obviously would be considered, or you might require to be shimming those in that application. Okay, the straight edge centre lines on the transmitter and reflector, as you can see with the little article on the left there, with the line going straight down the middle, that's obviously a good alignment. That's reflected in the Easy tooling with the green line going down the centre of both lines, both tools. You know, we basically got the ideal alignment for your drive. Okay, on a offset, parallel misalignment, the laser lines will appear offset to the centre of the reflector, but not the transmitter. So as you can see there, that's your standard for your parallel shafts, but they're not aligned and slightly running out of centres. The angular misalignment with the Easy Line tool. You can see there that the parallel of the shafts are not running parallel, so you've got one slightly off centre and slightly tilted to the side off it, the centre line. Second plane angular misalignment with the Easy Line. You notice there that you know, this is, if you've been around, you'll obviously know that the motor is obviously twisted to the left or giving it incorrect parallel, but also it's shimmed incorrectly where it needs to be brought into the same height. So that's creating that twisting effect. I think we've all seen those in our time. Okay, correcting the real world of misalignment. All right, what we have to do firstly is obviously correct the second plane angular. So basically with the indications there, we talked about the motor being required shimming, and you can see from the actual diagram there that shimming the motor will obviously bring those pulleys back into some sort of parallel. Then you're correcting your angular misalignment, so the motor angle by the twin screws. So that's actually adjusting your motor alignment with your motor bolts or screws to adjust those in or out, or pulling it back into parallel to get the shafts running parallel. Then the final correct parallel misalignment is obviously adjusting your pulleys on the shafts. Okay, detecting and correcting misalignment. Obviously, this is started off with the belts off. So the first, as mentioned before, we mount the sheaves, sprockets loosely on the shafts, apply the EGZ align tool, correct the second plane as we did prior, then correct the angular misalignment, correct the parallel misalignment, place the belts on the pulleys and sprocket or sprockets, and then apply tension by winding it out. Then obviously reviewing the alignment as you bring the belt into tension. Obviously, this is a lot easier to do with an easy liner tool than be it a straight edge or a piece of string. Drive application examples. Okay, this is obviously a second plane angular misalignment. Oh, sorry, the second line misalignment is okay, but note the angular misalignment. So you can see basically we've got angular misalignment in the red there, and the offset line in blue where it's slightly off the shafts and not in line. Okay, so obviously correcting that, we can jump into the next slide, and you've actually remedying this by slightly fixing the angular misalignment by twisting the motor or rearranging the motor on its bolts. And then obviously bringing your pulleys into line off the shafts. Okay, the next one again, the drive application example. The correct parallel misalignment, just drive pulley position to the correct parallel misalignment. So in this case, you have in the red, you have parallel misalignment, which is fixed. Then we have the offset face with about 2 degree any rim offset. So you can see there that we need to bring these lines into check or to alignment. And on the next slide, you're actually adjusting those into where the lines are actually parallel. Belt installation. Obviously, we turn the motor base screws equally increments for installation. So if the motor's not skew width, you're actually trying to draw those bolts in together, so they're actually not going to distract any parallel on them, as per this one here. But you've got the push and the pull, which is obviously adjusting it in or out. Okay, mainly on a synchronized belt, this will come into play a bit more, where the actual belt will track. It tends to want to track on a downhill run, you might say. The example here on the far right, you'll see the actual belt. You don't have to actually start this up. If the motor's free, you can actually just turn it over and the motor will slightly track. Why a belt tracks on a synchronized belt? It could be the makeup of the belt itself, the strength and weakness, but most commonly it would be due to the misalignment of the pulleys. How do you correct that? You'll notice there it's actually tracked off the pulley, so to speak. In some cases, certain pulleys are at certain widths. So you've got, say, your driver pulley here, it's a bit slightly narrower than the driven pulley, so it tends to want to run out a bit and over the actual driven pulley. So it's really just a simple task of backing off and pulling the driven pulley out to give you a better alignment in that area, as per this one. Okay, these are offset brackets which come with the Easy Line tool. These obviously come with a standard spacer, which is the 12mm one, but you can obviously get the 19mm, which obviously widens the spacing of the pulleys. You can see here, it's not so much here in Australia, but you can get some overseas drives that do have different parameters on their pulleys, on the rims, and this is where these come into play. It's not that common here, but these spacer brackets are available if required. As you can see there, putting the brackets on the basically the hub width, it just allows you to have the reflectors being in a position where they can get the correct readings. Okay, this is more the facts and figures. What is a practical number for a misalignment? The ideal number is obviously 0. The better the alignment, the more effort you put into getting it aligned, and the better off you'll be, and the longer the life of the drive. There is a bit of a formula on this. On a synchronised belt, you've basically got 1.6 mil per 305 millimetres, between the emanator and the reflector. Now that's basically your space here of your 305, and obviously your 1.6 there is obviously your parameters that you can work to. So ideally you want to get that green line closer to your black line as possible. There is a bit of a tolerance on that. And on a synchronised drive, obviously it's 1.6. Oh, sorry, a V belt is 2.5. Sorry, covered that. Sorry. Real world misalignment. We talked about this previously there on the belt tracking. Gives you a bit of a picture there. Obviously, the slight exaggerated to a degree, but you're getting the pulleys just slightly out of parallel. So it gives you an idea which way the belt will track. As mentioned prior, a synchronised belt will always tend to track downhill. So the better parallel, or the better you have the pulleys at parallel, you're going to reduce the risk of tracking. Like I said before, when you're setting these up, it's an ideal scenario to wind them over, and you tend to get an idea of which way the belt is tracking. If the belt doesn't actually wind back when you reverse it, well, you're most probably, it's an ideal drive setup. Okay, that kind of covers the major parts of the alignment. This covers some of the GATES training programs that we obviously do, that we can assist in the field and also on site. We do have programs that we can run and tailor to the courses. It covers some of the things of belt identification, belt construction, features and benefits of the belt drive problems, belt pulley inspection, very big part of it, preventative maintenance, guard maintenance, shutdown procedures, pulleys installation and alignment, which we've covered a bit on today, belt tensioning techniques, retensioning periods, when and how, training, use of tension and laser tools. These can all be done on site if required, and trouble failure modes. Like I said to you before, ideally the courses can be run for a maximum of 12 people. It's really up to 3-4 hours. And it's really just up to you. What you want is how we can deliver them. To cover it on before, outside of the training, obviously we can support in the field with just basically technical services. Quite often we're out there looking at drives, failures, can assist with obviously laser alignments, tensionings, it's really just covering if you've got a problem drive, we can usually help you through it. We did cover some of the maintenance tools, or one of the major tools there, the EZ-Line. I did have a question on the EZ-Line on what the actual distance is. Now, currently we have two laser tools, which is the AT1 there you see at the top. That is a red laser, more suitable for indoor use, and the distance on that is about 2.5 metres. The EZ-Line green, which was predominantly promoted or shared in the demonstrations there, that's obviously a green laser, and it's got a distance of about 6 metres. These are coming kit forms, which you'll see on the left-hand side. That's the maintenance kit that comes with the tension plungers, the sonic tester, belt wear gauges, and the obviously the easy aligners. On the right-hand side, and this is pretty new to the market, I don't think anyone would have seen this to date. This is a synchronised belt aligner. It's really come out in the last 2 weeks. We haven't got much information on what you're seeing there, but it's obviously a more compact tool that can be used. And if you'd want to find out a bit more information on that, we can certainly share that in the not too distant future. This basically comes to the end of it. As we did mention in previous ones, Gates, we can obviously, if you have inquiries in these times, we can obviously set up video conferences, telephone calls, or emails. The link there obviously is a request. If you want to catch up with us or talk to us about anything that you feel you need to want to talk to us about, we're available for that. Our next webinar is on Tuesday the 16th of June. It starts about 10 a.m. as these are, covering Polychain. It is Taylor and Danielle. They're actually US presenters, and they'll obviously give you a bit of an overview on what's coming up in the market in Polychain. So that's on the 16th of June. If you've got any questions or anything you'd like to ask me, that's my email address. You can fire off an email to me if you have a question. And I think that basically wraps it up for me. If you've got any questions, feel free to send them through. We've got a couple there, which we might have to take a bit of offline and we'll respond to you. But if you've got any other questions about that, this one is on when you have idler pulleys. Obviously, just if you do have a 3-pulley drive system and you're trying to do an easy alignment, one of the better things to do is obviously start off with your motor pulley as your parallel. This would be then, because sometimes on a 3-pulley or an idler pulley, one of the pulleys might be blocking the 3rd pulley. So you would go to your 1st pulley, which you've got vision of sight, set that up, and then proceed on from your 2nd pulley to your 3rd pulley to get your alignment. Yeah, that would be the best way to do that. But obviously keeping in mind that just to check your shimming on any bearing mounted idler. Okay. Seeing if there's any other questions. Okay. Give it a minute if anyone's got any, but if they haven't got any and if you want to carry on your day, thanks for attending. Appreciate that, and hopefully we've put some insight into laser lining and it's going to make your next drive setup a bit easier. Thanks for the call and appreciate your support. Thanks again.